Our next question is from GATE 2016, Plant Design and Economics for 2 marks. A vertical cylindrical tank with a flat roof and bottom is to be constructed for storing 150 meter cube of ethylene glycol. The cost of the material and fabrication for the tank wall is rupees 6000 per meter square, and the same for the roof and the tank bottom are rupees 2000 and 4000 per meter square respectively. The cost of the accessories, piping and instruments can be taken as 10% of the cost of the wall. 10% of the volume of the tank needs to be kept free as vapor space above the liquid storage. What is the optimum diameter for the tank? Let's start with the solution. First we will see the volume of the tank. V is equal to pi by 4 d square into h, right? Now they have given one thing. They have given that we have for storing 150 meter cube of ethylene glycol. We want to store the 150 meter cube of ethylene glycol, that, and they have given one more thing. They have given the 10% of the volume of the tank needs to be kept free as vapor space above the liquid storage, right? So total volume of the tank will be given as V is equal to 150 plus 0.1 into V. 10% of the total volume. This is the total volume. What will be the total volume? Total volume is equal to ethylene glycol volume plus 10% 10% of the total volume, right? So from this we get volume of the total volume of the container will be 166.66 meter cube, or we can say 1.66.67, whatever you want, right? So we will put the value of V, then we will get from here h is equal to 666.68 divided by pi d square. I have multiplied by 4 this, right? Now first we will see the cost. What is the total cost? Cost is equal to, you can see here, pi dh. Pi d is the wall surface area. You can see here the cost of the material and fabrication for the tank wall is 6000 per meter square, right? They have given 6000 per meter square. So we know that for a cylindrical vessel, surface area of the wall is given as pi dh. So we will multiply with the 6000. You can see here it is in rupees per meter square. So when I multiply the area with this, then we get it in rupees, 6000 into pi dh. Plus, now they have given one more thing. They have given the 10%. The cost of the accessories, piping and instruments can be taken as 10% of the cost of the wall. 10% of the cost of the wall. Remember this. So I will add 10% more in this. 10% of this, right? Plus, they have given for roof and bottom prices. The same for the roof and the tank bottom are 2000 and 4000 per meter square respectively. So since it is a cylindrical vessel, so surface will be circle. So area of the circle is pi by 4 d square for the roof and 4000 for the bottom, pi by 4 d square, right? So it is a total cost. After solving we will get 6600 pi dh plus 6000 pi by 4 d square. Now we just need to convert it in d. Since here is a h we will put the value of h is equal to, from here h is equal to 666.68 divided by pi d square. From this we get this equation. Now we need to know the optimum diameter for which the cost will be minimum, right? So we just need to do the partial differentiation with respect to d. Del c over del d is equal to minus this plus this. You can see here d square and here minus, and it will be 2 pi by 4 into 2, it will be pi by 2. So from this we will put it equals to 0. After solving we get d cube is equal to this. Then finally we get d is equal to 7.758 meter. This will be the final answer. From this, from the options given, from the given option D is nearest answer. So 7.8 meter is the final answer. Option D is correct. So thank you. Please make sure to like, share and subscribe my channel. Thank you.